Hello. Today I'm going to be talking about my exoskeleton project, or as I like to call it, the Junk Nominal Kinetic Integration Janky Power Legs. And it's going to be a pretty simple circuit. It is just going to be about 10 linear actuators for the legs, which means there's going to be a bunch of these buttons. And how it's going to work is it's just these two buttons, when both pressed at the same time, will connect the positive and negative to a linear actuator, causing it to go in a specified direction. Now, I'm going to be actually having two of these units per linear actuator. And with this one, I just beefed it up a bit, gave it a little extra housing so it's easier to press both buttons at once. And they're going to be on opposite sides of the movement point. So, being on opposite sides of the carriage, pressing the button on this side will make the linear actuator go, let's say, forward. And then pressing the button on this side will make the linear actuator go backwards, essentially making a polarity reversing switch. And since they are on opposite sides of the carriage, ideally there won't be any short circuits and, like wire meltdowns. Now, since there's 10 linear actuators, I'm going to be needing about 20 of these units for both legs, which means probably about 40 push buttons in total, and man, that's a lot of buttons. I'm actually not sure if I ordered enough buttons. I'm gonna have to check that, because I think I only have 30, so I'm gonna have to get a few more. But then again, for two of the linear actuators each foot, they're going to be articulated by these switches, so that probably ought to cut down on my button count. But then again, these buttons are pretty inexpensive. It's like $10 for 15 of them, so that's pretty nice. And if we'll focus, I'm going to be, modifying this a little bit, because this whole PVC structure is a little bit too large for my purposes, but it does demonstrate the principles of the linear actuator system fairly well, at least for the ankles. I actually took one of the ankles out to power Marduk's power mitten, so I'm gonna have to put that back in. But with this dual axis system, it's going to be doing a lot of the joints, like for the hip and the ankles. It's going to be that, and for the knee, I'm just going to borrow Marduk's steering linear actuators, and get some quick connectors. Where'd I put those? Here we go. Like some automotive quick connectors, so I can easily swap the linear actuators back and forth between the projects. I mean, I'll probably only be borrowing like 3 linear actuators from Marduk, so the janky power legs will mostly stay intact. Yes, the problem is that Amazon seems to run out of linear actuators fairly quickly for that price, so I'm probably going to be going to a website that a friend recommended to me on Discord called Banggood, which does like direct from China products, and they seem to not run out of linear actuators as fast, probably just because, not a lot of people know about them. So, I'm looking forward to working on the JNKI power armor, and, hopefully I could, release a Blender file that just has like, everything laid out, and it will be open source powered armor. Wouldn't that be neat? And one other thing. These linear actuators are going to be fairly slow. I mean, they only do like 12 millimeters a second, and you're thinking, that's not very fast. It's going to be slow power armor. And you're right. It will be slow. Just, this is so I can figure out, how it's going to work, get my coordination set up. Then what I'm going to do is I'm going to start overclocking these, pretty much. Running more voltage in them than you really should, because while you technically can do that with motors, you have to worry about them overheating. So what I'm going to do is do some sort of active cooling system. Either getting some Peltiers off Amazon, which are like $12 each, and they're essentially like little metal panels that do some magic mumbo-jumbo with electricity. One side gets hot, the other side gets cold. That would be good for cooling these down. Or finding a good heat sink and doing liquid cooling, kind of like a PC or a car. But the problem would be finding a a heatsink that could get on this curved surface and wick the heat away properly. Otherwise, these motors are going to have a bad time. So, I guess that will be all for today. If you do enjoy my giant robot content, be sure to like and subscribe. And I will see you next time. Bye-bye.